Welcome back, episode 12, VRF Tech Talk podcast. I am Donald, and he is Roman.
I am also Donald.
Oh, I'll be Roman today.
We've taken way too long to get you guys another episode, and we apologize. Our work lives have been a little crazy and hectic. We do this for fun, not for sport. Maybe for a little bit for sport, but yeah. So we got a lot of stuff to cover today. We're gonna just kind of wing it on the topic side of things, just because VRF sometimes isn't planned and is kind of all over the place. So maybe just talking more about things that we're working through right now and issues. One we just actually talked about that's probably not that much VRF related, but yeah. So Donald, do you have anything specific you want to talk about really quick before we jump into? I'd love to bring up that smoke detector topic we just talked about. So
yeah, let's go for that right away. Let's just go.
Okay, so this is not VRF related, but it is also VRF related. So a lot of applications you'll find larger commercial setting, whether it's your Daikin Rebel units or roof pack units or custom DOAS with VRF, whatever flavor you decide to choose, makeup air units with EEV kits. We always have to deal with the problem of smoke detectors and where to put them and how to measure them. And I've got a project right now where the smoke detectors are randomly tripping in the return air ductwork. And so we are talking about a very specific brand, which I'll leave nameless for right now. But, it's one of those things where we get so caught up in looking at the data and looking at the information on the service checker and what's going on. And obviously this is a smoke detector, so it's not tied into that specifically, but it's still a nuisance and it's stuff that we have to deal with. And not a lot of people talk about smoke detectors as a whole, but you were saying, Donald, that water, moisture, vapor trips smoke detectors.
Any particulate matter, anything that has a mass, I guess you could say. I had to deal with a very similar situation, and it turned out that it was the RH in the ductwork, right? Because right after a cooling coil, RH is going to be nearly 100%. So we're going to have moisture in the air. And that moisture in the air was getting into the smoke detector and tripping the sensor and saying that there was a false trip. But we don't think, we think of the smoke detector of it's detecting smoke, but like, how does it detect smoke? So inside of a smoke detector, there's just a sensor that basically reads a light beam, and when that light beam is scattered through whatever matter, right, smoke or anything that can scatter that light
moisture,
beam, it's
water,
not going to make it to that sensor, and it's going to trip. So again, like moisture will cause that to happen. So
but you were saying that your unit was specifically turning off, and then the RH was climbing, and then it was tripping, or
it was when we had a cooling call, the RH obviously spiked because we started cooling. And then we would have those nuisance trips.
Nice. Okay. So, and that's probably what's happening with us. But also the other side too is realizing that smoke tube differential is a thing. Like, so when life safety to get signed off on most mechanical inspections is they're going to want you to measure the differential between entering and leaving on the supply and return of the smoke tube. And if that differential is above 0.8 inches for most manufacturers, just the velocity of air flowing through there, it's going to throw a ton of stuff at that sensor that's not supposed to be there. I mean, even certain levels of humidity flowing through a sensor at that rate of speed can cause a problem. And that goes back to, airflow, making sure that it's one, positioned in the right spot on the ductwork, but also two, that it is, the system is good and commissioned correctly, right? If your system is operating at 3.5 inches of static, you're going to want to make sure, it's high velocity, high pressure. You're making sure that one, your duct detector is rated for something around there, but also the way you install it and you measure it, check to see, maybe my tubes need to be 90 degrees on both sides to slow that air down. It's just the same, what's required.
The same way you would sample air for taking a static reading, right? You got to make sure that your pickup is in the right direction, right?
Yeah.
Like every smoke tube I've ever seen is like just a perforated tube, right? And it picks it up from that sample, and it's kind of I don't know if this is a good analogy, but like kind of like a vent for a furnace, right? Where it's a concentric. But if you have a differential, yes, then like if you have two inputs for two different sources, then you gotta make sure that you have a differential, right? Because if you don't, then what is it sampling? It's sampling nothing.
Yeah. And so you're asking, what does smoke detectors and smoke tubes have to do with VRF? And I've seen smoke detectors wired in on communication lines where they're like, well, if there's a smoke detected, we need to just go ahead and just disconnect everything all together at one time. And the building goes into U4s. And so you got this thing where it is life safety, but there's a place to put it, whether it's on the T1, T2 contact. So that would be my ask to you then, Donald. So I'm having issues with this on a Rebel applied equipment, right? And we're going to get it resolved. We're getting it resolved today, actually. But if we are talking about integrating smoke detectors or life safety stuff with VRF, the question always is, where do you put it? And how do you set it up? Because that's the biggest caveat too. I mean, we don't want to break comm lines. We don't want to, put it on 3-phase contactors to pull voltage from the outdoor unit. Every piece of equipment is a little bit different, but there's a place to put it. So let's talk most complex.
Most
EEV
complex
kits.
is going to be the easiest systems, right? It's going to be the 4-wire mini splits because they don't have anywhere specifically to put it.
And you've run into that, huh?
Absolutely.
Oh, yeah.
In that instance, right? Like the only thing you really can do is break line voltage. Now, do you break it at the indoor? Do you break it at the outdoor? Well, the outdoor powers the indoor, so there's really no good place to put it, because if that current pressure is ramped up and then we have that trip, right, then you run the risk of damaging that piece of machinery. So I go back and forth on this. Do we break? I would prefer breaking the wires going to the fan coil, the power coming to the fan coil. But in the same aspect, I kind of feel like if you break comm, then it shuts down the unit. But
sure, yeah, but break the L3 wire, right?
Yeah.
Not with your condensate pump. Or maybe, I don't know. But also some mini splits also have that 2-wire jumper in the back right side for a drain alarm or something like that. So, I mean, whatever shuts the system down and stops the fan. And that's the biggest part too, is that depending upon your jurisdiction, they're going to make you test it, or they're going to require you to test it some way. So making sure that you know what you're doing and that it trips is kind of the big thing. So you say that's the most complex. I'm thinking like EEV kits and custom DOAS units. Where are we landing that on those larger projects?
Well, I guess it really depends on who's controlling the fan, because at the end of the day, what we wanted to do is stop the fan. So if the EEV kit is not controlling the fan, then it's got to go to the VFD or whatever is controlling the fan.
Yeah, and I guess VFD would be just what e-stop, right, on the VFD. Yeah. But then how does the system know that the e-stop has been enabled back to the EEV controller to throw an alarm for the system, I guess? Superheat sucks.
So many
compressors heat liquid.
That question comes up all the time, is like, so what happens when we don't stop? We lose airflow on an EEV kit and we don't stop refrigeration. Flow. Doesn't it have freeze protection? Is it going to stop itself? It's like, well, eventually it will stop itself, but like that eventually is potentially a death sentence. So
sure, liquid down the suction line.
It depends on what the full control package is. If there's a vendor that's doing controls, they can have an output from the VFD to say, hey, smoke tripped, shut down the DX side, or just go directly to the DX, right? Like we have an input and output on there for start stop. So wire that in parallel with an output from the VFD. It just
stop and then stop DX kit.
Well, you can just use one of the relay outputs on one of the VFDs. Like I'm more familiar with the ABB, so we have 4 relay outputs that we can tie into or interlock basically with that e-stop. It says
gotcha. Like, so let the drive, once it gets the e-stop command, also dictate to the kit to turn off.
Sure, absolutely.
Yeah. No, and we've seen that before too with other systems that were not VRF related, where you've got these remote condensers, and Carrier is one of them, where the remote condenser itself has the control brain, and the indoor unit is literally just a VFD drive. Yeah. And if you don't, and a lot of guys will jumper out the e-stop on the outdoor unit instead of landing that e-stop wire to the VFD drive, and so the drive is always enabled and the outdoor unit is always enabled. And then you'll find it when the schedules aren't simpatico between both what drives the drive, which is, the BMS system, and then the outdoor unit, which is controlling the cooling loop, you'll find that it trips off on low suction pressure all the dang time at night. And that's because the fan has been told to turn off, but the outdoor unit doesn't know that the fan is turned off. And because there's no e-stop, there's no enabled showing the fan enabled. And so it just runs wild. We had a client that was dealing with an issue for like a year before they came to us and we investigated. And I'll be honest, it scratched my head for a while. And but it was exactly that. It was the unit was driving without knowing where the fan drive was, or that the fan wasn't running. And so it was kept tripping off on low pressure, and it would lock out the unit after 3 tries. And then they come in the next day and they'd be like, it's hot in here. We reset the unit and it's running great now. So
yeah,
a lot of little things.
I'm just seeing, I think I have some drawings that I've put together for various EV kit projects that I can kind of share with what we've done in the past.
But it's always one of those things. If it's not smoke detectors, it's always something else too, right? It's a fire panel. Right? Yeah, it's a fire panel. It's a building management system. It's interlock between a bunch of other stuff. We don't have to. Everybody thinks, so if I just break the comms, it's going to all stop because of comm errors. And it's like, yeah, but you also don't realize that
eventually.
we don't want to be sending data packets through relays
Right.
or safety devices when it should just be board to board communication, right? Those the
Right.
biggest thing is that we don't want to, especially if those relays, have an induced current to stay open. What are we losing along
That's
the
kind of
way?
what's
Yeah,
looking.
next to let's run all our data packets to a giant magnet. Sure, that'll be okay. We shouldn't have any communication issues or random ghost errors on this EEV kit,
I
or
think
yeah, Lord forbid, like a 12 kit system.
yeah, I think the hey, don't give me crap. It works, okay? Uh, the
24 kits. Take that, chillers. We
the
got your number.
the one thing to remember is the communication signals are not 24-volt open close electromechanical signals, right? We're
Yeah,
there's information, you touched on it, there's data packets, there's things that run through those wires. It's not just 24-volt AC on off.
yeah.
So the more things you put on there, the more resistance you put in there, the worse you are, right? So the same thing when you're dealing with vacuum and you have your manifold into the hoses, into a ball valve, into your T for your micron gauge, right? The more connections you have, the worse off you're going to be, right? And the same
Yeah.
thing is true
There's
with
just
communication.
potential points for failure.
Yeah,
And so, if I break my 24 kit system that they told you shouldn't build, Donald, with, 24 rib relays, and I run my comm wires to all those rib relays, I mean, you're going to get some pretty wild interference. Now I want to do that to see what it looks like on a scope. But it's exactly that. It's don't try to, break the thing is most important and actually land it where you need to
right.
go. And I think water cooled is probably the worst example of that because the manuals are so vague as to what does what on those systems in general, where it's, Lord forbid you want to do multi flow modulating valves on water cooled heat recovery. The amount of accessories that you have to add to make that work.
I mean, it's all possible, but like, yeah, at the end of the day, is there a simpler way to do this where you don't have to worry about that?
Yeah, does this relay output do this? Does it do that? I mean, I always say to test it because the manual says one thing, but logic dictates the other.
Yeah.
Did you find the wiring diagram?
I did. Let me get to the right page here. Let's see here. How
But
do I how do I
it's
share my screen?
dang boomers. That's not you though.
Sometimes I feel like it, man.
But I mean, I've seen it too, where it's like, we didn't break the life safety device. We installed the system, we did the comm wiring, but a third party contractor came in and said, well, this is their control wire. Let me just snippety snip. And then they daisy chain in and you find it later down the road and you're like, wow, why would somebody do that?
Yeah. So here's a dual kit, dual VFD, exhaust and supply VFD, one smoke detector, and this is how it worked, right? We use our contacts on the VFDs to shut them down or start them. We're using our relays to make it work. I mean, here's the sequence of how this was designed and how it worked.
Nice.
Yeah.
Yeah, it
So,
seems pretty simple. And
I mean,
well, it is and it isn't, right?
and this is just a jumble of squares and wires and lines, right? But it really does take a certain kind of person to read through that and go, oh, okay, that makes sense. Now I knew exactly what's going
Now,
on.
what about parameters? Are you're changing parameters to energize the relays that you're talking about, or are those already e stops in themselves?
So it depends on the macro that you're using on that drive, but DI4 is always the start stop or the emergency. So as long
Gotcha.
as that's set, you can go in and change the relay outputs to
And
do
then
whatever you want.
making sure it's set to auto reset.
Yeah.
That's the biggest one that I always find too. It's like,
Well, so that brings up a touchy subject or a good topic is should any fire life safety call be automatically reset? I don't think it should be.
well, no, but when we're talking about, I see a lot of guys who change out VFD drives for like Danfoss compressors, and they don't go back and set the auto reset. And so anytime there's a manual
Hmm.
trip, whether it's low superheat or a power cycle,
Sure.
the drive locks out, and rightfully so because it's not auto reset, and you have to go and jam the button on the drive on the
Yeah.
roof in the rain. Those are the things that. But yes, like you're saying, life safety, should it be auto reset? No, it should be when the contact has been cleared and you have the demand signal again. But it shouldn't require you to go and actually manually touch a button to say, okay,
See,
you're
I
good
think it
now.
should.
You
right?
think it should?
Absolutely, because there's so many situations. Say in the instance of you actually do have a fire, right, and that smoke detector trips, the building automation system isn't integrated and it's just a standalone project like this. If that signal is cleared, but there's still stuff going on in the building that could potentially be harmful to the human occupants, like we don't want it to automatically reset. We want somebody physically to say everything is cleared, everything is okay, we're good to start again, and then you can start it.
It sounds like they need a really big red button in the lobby that says reset AC system.
And maybe that's it, right? Maybe that's what you do, but I think it does should require a human's input to say this is safe to run again, go ahead and run.
Or like one of those like only the fire department has the key to turn the switch or whatever.
I wouldn't go that far, but
I gotta call 911 to reset your AC system. Give me a
yeah,
second.
seriously.
Yeah, but it's good. These are all talking points, and they're like, well, you know, that we are getting a little off topic from VRF, but this doesn't always have to be VRF. This is also just commercial air conditioning as a whole, and the pain points that our clients see on a daily basis. Now, for me, when I'm the technician that has to climb through the attic and has to go, you know, over, you know, up a ladder hatch, then up the shin killer staircase to the parapet wall to the down another ladder hatch to get to the air handler behind two locked doors to push a button, yeah, I'm going to be a little frustrated and upset that someone thought this design was a good idea. But to your point, like it's all about liability too, because who's going to own that at the end of the day? You know, if I push the reset button and it turns back on and there is still a fire in the building, which I shouldn't be there, but you know, I'm accepting liability for, you know, running that piece of equipment. Now catch me if you can, but yeah, you know, it still brings up bigger points because there's a lot of getting into a deeper topic would be A2Ls, right? So we're getting into this R32 territory, R454B, VRF realm, and everybody thinks it's going to be the end of VRF, and it, you know, there's the sensor right there, and so it's an optical sensor, is it not?
I don't know. I haven't had much time to dig into this one. This is the Sensata.
Sensira. Oh, Sensata.
Yeah,
okay.
Whatever it is. Sensata.
Sensata, yeah. It's the one the Daikin's using for their R32 equipment.
Yeah.
The sensor that they say is a one-time use, but
no, this is not the one-time use one.
Okay.
This is the one from the FXTA, the new stand-up multi-position. So this is not a one-time use. This one,
yeah, 15. It's a 15-year sensor. Yeah,
something like that
with a field setting. Field setting to say you reset it.
This is the one-time use one.
Does it feel like Temu sensor?
No, I mean it's a brand in Japan that's been around for a while that makes it Nisha, Nissha.
Is it just a board? There's a plug and everything. Oh yeah.
Yeah. So this is the actual sensor module.
Okay.
There's a little CPU in the corner there, and then this communicates to the fan coil.
Nice. Okay. But that does kind of look like a one-time use.
But I mean, everything I'm reading from the manufacturer says it's not.
It's a liability though, right? And so this is something you and I talked about in the past where, yes, the manufacturers of these sensors say they are, first of all, you know, they've been trained to not be corrupted by corruption. They're incorruptible according to the information of what they say in their packets, right? So don't try to bribe them; they won't take it. But to the fact where they can't be degraded over the 15-year span that they say is accurate to detect these things. Now you've tested it. Have you tried breathing on it really heavily?
So
like someone who's run up a staircase.
This one particularly because this is let's look at the differences. This is a Modbus device, so this communicates Modbus to whatever it's plugged into. So like,
okay,
in theory, I can plug into whatever I want and just use this sensor. Sure. This one, from all the data that I could find, is a PWM signal that the pulse width changes as this thing detects or doesn't detect. I mean, I got a jug of R32 literally right next to me that I was spraying on it, and I couldn't detect a difference. But then again, like maybe I don't have the right concentration in the space I'm in. Do I need to put it into a container and test it?
Does it need a signal input to say, hey, start looking?
Right. There's too many things that I don't know about it because like there's not a lot of data on this. There's not a good data sheet that says this is exactly how it works, and there's like 6 different variations of this that all kind of allude to different things. And well, from what I can tell is that this is once it trips, it kind of locks out that CPU and says, "Hey, I can't run again."
Okay, gotcha. Yeah, and it's a field setting to reset it on the unit itself, or maybe it's disconnecting the sensor and putting a new one back in that clears the alarm.
Maybe it's
From what I see, it's
disconnect the
field
sensor and
settings.
well for sure the field setting on the Sensata one, right? Because
Yep.
it's a communicating device, right? But
When it's in the manual to tell us where to reset it.
but does that work? That's going to be a topic for testing in the training center. Here's is this
If
one
we trip it,
resettable? But I don't.
yeah.
We don't want to publish that and say, hey, you can reset these, because then like, are we breaking a
Don't let the
UL standard?
manufacturer lie to you.
Are we going to open ourselves up for liability in that aspect? It's like, but these are so cheap. These are like $40, right? So like, is it
Yeah.
worthwhile just to replace it? Absolutely. If you
Well,
had
and how often are you
if you
having
had a
a leak
leak,
too?
well, flares aren't perfect, and this is pretty close to a flare. So if you have a leak,
I use Leak Seal, so not have to worry about it.
Tell them VRF manufacturers.
Void my warranty. I dare you. But it's exactly that. So with A2L sensors, both indoor, boxes, because I'm sure it's the same thing in the boxes, right? The SSOVs, service valves.
I don't know. I haven't seen anything on that. I don't think there's an actual sensor in the box.
You think it's a detection of, hey, it's been detected at the indoor unit, isolate box.
Yeah, and I think I don't know if you've seen the pictures of it, but the new multi-port branch sectors are going to be able to be put into an enclosure. So I think there's going to be an external sensor that plugs into the enclosure.
Oh, it's an accessory. Got you. So put it in an enclosure. If that's a trash bag, so be it.
There's an actual like sheet metal
that they make.
Yeah,
man, I'm so behind on the times.
It's pretty cool. I don't know if it's going to be a huge thing, but it's around and designed for a purpose. So I mean, it's obviously going to use somewhere.
Well, my thing is obviously, hopefully, we're going to be a good 7-8 years down the road before we start dealing with coil failures and coil leaks. But these are things that we have to start thinking about life safety wise. Because the other side of that is okay, you have a life safety device using A2Ls. What is your mechanical jurisdiction and code going to require you to do to test it, either annually, biannually, at the start of the project, to show that each one? I mean, I've met some very passionate inspectors. That's the polite way to put it. What's required? I mean, California, you guys lead the charge in going above and beyond in the unnecessary, in my opinion.
Everybody's gonna be safe. I don't really know, because like that hasn't been brought up to me personally. But what I can say is there's gonna be a whole bunch of people I can ask on Wednesday.
Good.
That's a really good topic of like what.
It's one of those. What is the municipality's going to require? Because if they require to test smoke detectors, they require to test life safety devices to ensure that they do exactly what you say they do. If you've got a design where you have these isolated shafts with A2L piping, and it has a fan at the top or a detector in the shaft to run the fan, they're going to want to see that when it does the thing that's supposed to protect people, does it work?
Right.
And who tested it? Because usually the mechanical inspector or even fire marshal, life safety, wants to sign off on something like that. And so, have we been thinking about these things, doing these projects? Because someone's going to push back eventually, and then it's going to be like, oh man, this is a nightmare.
I'm actually sorry to hear me type. I'm actually going to ask somebody that right now, because I think that's a really good topic that I don't think has been broached by anybody.
No, and that's the thing too. Is like, do I walk? You obviously are not. Let me just go ahead and call out the basic of like, don't misconstrue words here. You're not going to walk around the building with a jug of R32 and start spraying it into rooms to show that it trips, right? Where we can't vent refrigerants to test life safety stuff. But there's got to be a testing procedure where you're changing a field setting or you're changing a code to manipulate the unit to show that it shuts the system down. I'm going to change this 0 to a 1 and say sensor tripped.
I don't know if you could do that, right? Because when you test a smoke detector, you go up and you fog it.
You do,
right? So like, how do you equate one that is potentially life safety versus one that is potentially life safety if you're digitally changing one or you're physically changing one?
Manipulating.
Yeah.
Sounds like we need to come out with our own VRF Tech Talk fogger that simulates A2L refrigerant.
A2L fogger. We don't condone venting refrigerant.
We don't. Yeah, no, sorry. We'll pull your EPA card
jug.
real quick. What's the video that's circulating online right now with the guy, the outdoor Daikin unit that broke, whatever?
That unitary, the cube. He's just up there, like he's like, That was the only
Talk
thing
to
I
my
could do.
supervisor. Yeah.
Yeah, my
Yeah.
supervisor's right there. We don't know the
Yeah.
whole story on that though,
We
right? Like,
don't.
did
Yeah.
the Schrader let loose, or did the pipe break? I
I
mean,
think I read
obviously.
somewhere that they were moving the unit and it broke the line connection or something like that.
Mhm.
And it's like, yeah, I mean, what do you do? Like, get the trash bag, quick, grab it, grab the
Yeah,
refrigerant.
well, that's not gonna. But yeah, like in that
We-
instance, yeah, you gotta let it rip, right? Unfortunately,
I've got a picture in my mind of a like 15 guys bringing like a bunch of black trash bags blown up like balloons off the roof. We'll just set it by the curb, right? EPA will come and get it. But yeah, it's those things too where the further down the hole we go with A2L detections and A2L equipment, I mean, we almost look to our brothers across the pond here in the UK, and we're probably going to get a bunch of messages about this. There's a few guys that from over there that love this podcast that are always like, when are we getting more episodes? They've been doing detection like this for what, 6-7 years now, maybe even 8. They'll correct me. But it's always been that like the way that I think that they get around with a lot of like the life safety stuff is, their equipment has a device in it that our equipment has. There's a line item. There's that leak detection EEV that we all talk about on VRV, right? What does it do? Why is it there? In the UK, the way they get around the leak detection protocols is they actually have a setting mode in the UK manual that tells you how to run the system. It's like a benchmark. So you run like test operation, but you run a refrigerant leak detection benchmark. And so the system will actually run using the leak detection EEV to benchmark the charge in the system. And then it goes through every 3 months, every 6 months, and it runs that test procedure at the same time in the same conditions. And it generates hey, is there a reduced capacity on this system because now there's a leak? And that's how they get around having to have someone go out there with a sniffer every 3 months to check every single
yeah.
crack and crevice.
I'm a proponent of running tests seasonally. I know you guys have given me crap on that before, but I think as long as the system is not in error, why not? Why not run it seasonally? And this could be that answer that you're talking about. Is like, it does two things, right? It verifies that your charge is still intact potentially,
because that's physics, right?
and
We're manipulating the system to see
right,
what it can do.
yeah, and we're making sure that the system is still running optimally based on the conditions of what we're at there.
Well, so this is my plug for Cool Automation, where it's like, well, they already have those algorithms and anomalies built out to where you can do the maintenance procedures where you can go and test it yourself. So the manufacturer doesn't do it now. But again, that's the thing. Like Japan and the Asian markets have been doing this forever, and yet we're still like in our infancy stage of wearing diapers around A2Ls. And so, they've got what is it? They call it the Sharudo technology. You guys are making fun of me. I found that on the Japanese website. Was it like 3.5 years ago, 4 years ago, where it was, they made those cartoon animation characters of superheroes, around the technology. and they call it the Sharudo technology. And it's basically the same thing where, the system has got the sensors, it's got the SSOVs, it's got an SSOV on the outdoor unit. The system, when it sees the detection, instead of isolating that indoor unit, actually pumps all the in charge into the outdoor unit and then isolates the entire system. So the whole system goes flat inside. It stores the charge outside, and then it generates an alarm to call your contractor because you've got no cooling or heating. And so
I think
they've got that.
We've heard that topic, right? Like, I think some manufacturer, I thought Train was doing that, where they're going to have like a forced pump down mode if it goes into a leak detection. And that's cool. It makes sense, I like it. Though. I think that's a great idea.
Yeah, well, because again, right, it's like you're doing my job for me. Pull it all down, and then all I have to do is show up, verify that is what happened, verify that it worked. There's nothing leaking into the line set. Line set's at 0 or it's at 12 psi. Then I'm going to pressurize with nitrogen, and I'm going to go leak check. But also, and this is the other side of it, leak detections are going to be indoor unit error code specific, right? And so that's where I'm going to go and say, hey, this unit is the one that has the leak, not just system wide. Because I swear, if we do system wide errors of leak detection, but don't tell me which unit tripped the leak detection, I'm going to be heckin' mad.
So far, from what we've seen on just like some of the nuisance trips on startups, it does kind of indicate that it's a specific unit. So you get a different code for, system error versus specific trip.
Gotcha.
What it is, I don't remember off the top of my head.
Yeah. Well, and it's just like, it's like going back to the thing that Daikin has now with the cross piping check. the with Emirion when it came out, and
Oh, the EA,
yeah. And so, but
I
that
loved
one
it.
is it's good, but it's also, in my opinion, hit and miss, because it's like, I ran it and it says I have 2 units cross piped, right? Because it stops when it sees it. So first ones it sees, it stops. It doesn't collect data and say, hey, I've got 8 of them. Good luck figuring out which 8 go to which. It says, hey, these 2 here, these are swapped. And then you run it again and you go, okay, these 2 here are swapped. I've seen it where it runs it and you get the 2. Okay.
Yeah.
Then I run it again and it's saying now there's 3. And you're like, wait, what? Now there's an extra one?
Have you ever done I like the EA26 because it forces somebody that there's definitely an issue. The check, right, when you go the EA26 cross wire check.
Yeah.
If you have more than one set of cross zones, it's impossible to use that code, because then you're just going to get a whole bunch of U9s and EAs, and it just is all over the place.
Wait, hold on. Yeah. How many? There's like there's like 15.
But here's the other kicker to that. If you have, this is climate driven. If you have fresh air on the backside of these coils and it's cold, it will trip the same EA because it's cold. So we can trick it. So it's not a catch all, and especially if you do that service check when you're
turn off your DOS.
EA, right, and you have a whole bunch of cold fresh air on the back of that coil, it's going to think that that's a cross zone. Sure. And then you're going to be going down that rabbit hole. So like, you get the EA26, great. Now you go through and functionally test with the service tool one by one. Don't let the machine tell you what to do. You tell the machine what to do.
And I even seen it too, where guys will run test operation in certain applications, and a building had humidity problems, and so they were dealing with microbial growth in like 3 rooms. Yeah. And the remediation process is like, it's high heat, man. It's like 90 degrees with air scrubbers, right? They want to get it hot and dry it out with dehumidifiers, and so they ran it while it was doing that, not knowing that they were in there doing that, because they were only on the roof. And so now the system is like benchmarking that it can't cool. It's tossing error codes because the coils aren't getting cold enough, and it looks like it's starved for refrigerant, so they add charge. And it's like this whole thing, and it's like, wait a minute, you should have just been like, you should have looked and seen, like, those aren't bad sensors. It is actually 100 degrees in those rooms.
Yeah.
Following it blindly, if you will. Trusting the machine to do automated processes without understanding other environments that contribute to these processes, right? And that's exactly it. It's just the dumping cold air in the return of the unit that's operating.
Right.
Having a unit working within a space that's well beyond its capabilities of 100 degrees, because let's be honest, we shouldn't be charging systems when there's remediation going on. Turn those units off and isolate and reschedule it.
Gotta get it started up. Gotta drive my floor.
Yeah. We're behind schedule. We got to make it happen.
Gotta drive my floor.
There's nothing. I'm not saying you can't do stuff like this. You can. You just have to take into account other things. I'm not going to run automated processes if it's not within the environment that it's designed for.
Right. It's not a design condition, right? Like if you don't have windows in your building, there's no point in starting your air conditioning up. That's pretty common sense. Have you been reading
my emails?
No, it happens all the time. It's raining outside. I'm going to do startup. We don't have walls. What is this going to do?
We've got to condition the drywall in the hallways to combat the numerous amounts of water intrusion that we're getting,
because we need to dry this linoleum flooring. Like,
have you thought about maybe putting windows in first before you try to dry your floors?
Right. I'm like, well, it brings me peace that it's not just my territory, but
it's everybody. And I get it.
There's deadlines. We get that.
When the construction process lands on the HVAC trade to make up the difference, it's always our job to make up the difference. And
it feels like
there's that liability clause of like, listen, I'm going to turn this thing on. You have no windows. You have no doors. I've got pictures. We're documenting it. I just want to let you know, when this thing has service problems later down the road, it's because we're running it outside of what it's supposed to run at. Right. And then they complain that the walls are sweating. They complain that the supply registers are sweating and dripping on the floors they're trying to dry out. And it's like, well, yeah, you got no windows and doors. Like, what do you expect? Like, we're conditioning a space. You've got a grill that's, 55 degrees, and the dew point is 72. Like, what do you want me to do? Like, I can't break the laws of physics for you. Wrap your building in a trash bag.
Yeah. Put a tent over it.
Call your local termite control specialist and have them tent it for you.
Tent your building, yeah.
But it's that too. It's the small little pain points, the small caveats. I mean, these are a lot of things that hold up and cause problems that we don't talk a whole lot about. Everybody talks about like service issues and compressor failures, but also these are the little nuances that, in my opinion, drive us crazy because there are things you can do and there's things you just can't do and you shouldn't do,
Yeah.
like breaking comm wires with, smoke detectors or life safety devices, or door switches, or condensate pumps, or insert service device here.
Yeah.
Yeah,
I mean, there's a place for all that stuff, but it really comes down to like somebody has to know what it does before somebody does it, right? Which
oh,
brings
I
up
got
another
one.
kind of topic of like support, right? So like say somebody goes out there and just does what they want and then they call for support, right? Like have you done any steps to verify that what you've done is correct or incorrect?
Yeah.
So if you're landing a condensate pump on T1, T2 and it's shutting the entire system down, did you realize that that's what was going to happen, or did you just do that because that was the easiest thing to do at the time?
Yeah.
So
Well, I mean, I that the bigger thing, like you and I want to talk about too, is technical support as
yeah,
a whole. It's easy to go through and ask for help when you feel like you don't have anywhere to turn, and sometimes it's less about getting that detailed expert opinion and more so of just having someone as a sounding board to talk through what you've done so far to know what the next steps are, because that's a part of it too, is it gets real cloudy really quick. And sometimes I have people I just call and I don't need them to give me the explanation of what the answer is. I just need them
right,
to tell me what the next step is according to what I'm telling them and what I've seen.
right,
These are the things that I've seen, these are the things that I've done, what should I do next, right? um, that's a lot of those support calls.
right. But I think you hit the nail on the head. There is these are the things I've seen and these are the things I've done, right? But like, what about the people that haven't seen it or haven't done it, right? What
Yeah.
are those people any more or less entitled to somebody's time because they haven't done anything yet?
Yeah, and the other
I
side
don't
too
know.
is like,
I don't really have a good
getting,
answer for that.
yeah, no, and I don't either. And I see people, and the group is great because your level of experience doesn't matter. You've got a question, and even if it's super simple,
Right.
someone's going to have an answer for you. But there is this level of um, patience that starts to wear away at some point, where you're constantly coming back with the same routine questions that are easily answered in the manual or training to get that quick fix. And I was the same way at the beginning too. It's like, why do I need to spend my time after hours or whatever to do the research and homework when I can just ask the question? And it's like, well, there comes a certain point where your questions are all related to the same thing. How much information have you done research or homework on? But then I think there's
Right.
also a flip side to that too. There's also doing too much homework and deep dive without having any of the concrete information that helps you make a
Yeah.
diagnostic.
Yeah.
It's the two ends of the spectrum here.
It is. I mean, like there's. I'm not going to say too much education is a bad thing, right? But like too much self education can be a bad thing because you're opening yourself up. If it's a topic you don't understand, and you go on Google and you're looking at every link and everything that AI is telling you, and then all of a sudden you're in this rabbit hole where you're like you're troubleshooting why the Earth is round, right? And then like all of a sudden you're in this place where you shouldn't be. Uh, that's
That's wrong.
not
First of all,
helpful.
Earth is flat, by the way.
It's a and there's a dome. But to a point is like don't overanalyze things, right? Like
Sure.
don't take yourself down a path of uh the darkest rabbit hole that you could find, like doom scrolling support, right? That's not a good thing.
Well, and it's no different than the example that I usually give, and that is, so you have a problem, and so you call your doctor and you say, "Here's what I think I have from WebMD," right? And without saying that, because no one ever admits that. They just say, "This is what I have."
Yeah, but we
Um,
know.
AI has told me what I have. I
Yeah,
already know. I just need you to sign a prescription for me. And I call my doctor and I tell him exactly what it is. Now, the doctor, instead of being a diagnostician and going through all the checks and paces to see if there's anything that you're just overlooking that might be a larger symptom to a bigger problem, he goes and he does super detailed research on the exact thing you said you have. And then you come in and he's like, yeah, no, I did the research and you definitely got that. Let's give you some prescriptions, right? No, doctors don't do that. Well, they're not supposed to do that. Maybe you need a new doctor, but one of those things is they look at it as a whole. You've got to look at all the symptoms, right? You can't just predetermine what the problem is without looking at any of the scientific facts. Because as soon as you go down that rabbit hole of creating your own tunnel vision of like, I'm only looking through these binoculars on the system, then you're going to miss some of the things that might not even be the issue that you thought. It's a bigger symptom to a much bigger problem. Because you and I both know that most VRF systems are not installed correctly or maintained correctly. And so the likelihood of finding only one problem is like a unicorn, 1 in a million. You're going to find that it's got a bad compressor, it's got oil traps, it's got faulty sensors, and it's got a refrigerant leak. That's a VRF system in the wild, right? Not to say that the technology is flawed, but that goes back to the bad installation and the bad maintenance. You're never going to go and be like, it's only this bad sensor, right? And it happens, but it's very rare. But if you go there and all you look at is the sensor, like these are my sensor goggles, like that's the only thing that's bad,
right?
But
that's how you get a part cannon, right? Like that's how you get continued work, right? But no, like I think to sum it up is like don't look at a situation under a microscope. Look at it with a macroscope, right? Look at the large picture, like you're saying, is like don't fixate on one item when this is a system, right? This is a large system. There's lots of items that can contribute to that symptom. So look at it as a macro, right? Look at the big picture before you decide that you're going to replace that temperature sensor that probably has nothing to do with the problem.
Mine is like, what would Sherlock Holmes do, right? Like if this was a murder and I'm trying to figure this out, I'm walking around, I'm looking, I'm listening, I'm quiet, I'm trying to observe, I'm being observant, whether that's in the data, whether that's what it looks like. You can easily tell when a compressor has been changed more than one time. You can easily tell when the system has not been maintained correctly, the screws are stripped out, the panels are falling off. There's multiple compressors on the roof. There's oil stains all over the roof under multiple systems. There's copper stubs sitting around. There's compressor covers, electrical covers laying around the roof, accessories. These things are the stuff that we can observe when we're running calls and when we see equipment. This is stuff that plays back into maybe it's not specific to my system that I'm working on, but it does give me a good idea of what's been done on the site. Right. It gives me a good idea of how the client maybe prioritizes these repairs. Maybe they don't like to do it at all. Maybe they do it themselves and they haven't admitted it yet to anybody. That's going to change the way that I look at the system. I'm not just here to fix the sensor error code. I'm here to look at the entire system as a whole. And also, why is there a compressor installed outside of the cabinet on that unit over there?
Creative on that one. But I think back it up a little bit. I think your first tool for diagnosis is always eyes and ears, right? Yeah. What do your eyes see and what are your ears hearing, right? And that's not to say like the machine. What does the machine sound like? What is the customer saying? What does the symptoms sound like? What has been told to you that you heard could be an issue, right? Use your eyes and ears first.
But it's also asking questions too. They're going to relay the information that's creating the most pain right now. It's your job to then go deeper than that and say, has this happened before? Is this normal for you guys? I don't know. I just started, but you could talk to Bill. Bill's been here for 5 years and you'll go talk to Bill and he'll be like, yeah, that system has been a problem since day one. Yeah. Here's my notebook of all my notes of the calls that we've run on it. Right.
Right.
They're usually the first to be like, oh yeah, here it is. That system again. And it's just being open to second guessing yourself. Like we don't want to be comfortable with never coming to a diagnostic or diagnosis, but you have to be open to reevaluating the facts. If something is showing you something else and you're like, no, I definitely had it, but these things say something else. It's like, you got to be willing to say, okay, I got to throw this in the trash and start over. Yeah. Or I got to step back and be okay with it's something else too, or it's bigger than this.
I think the good example is the job I was on yesterday. I was messaging the guys about that a random E2 on a VRV3, and like it doesn't make sense. There's nothing grounded. The compressors don't show ground. The solenoids don't show ground. That entire safety circuit is good. The compressor has just been replaced, but the first thing I did was push in that contactor. I said, "Man, that compressor doesn't sound healthy. It's brand new. Like that doesn't sound healthy." But okay, well let's move past that for now. So go through the rest of the troubleshooting, and then the final thing I did was I put an amp clamp around the lead, and when that compressor trips, it's pulling like 30 amps when the E2 trips.
Yeah, it's not a
You push
grounded
in the
compressor.
contactor, it runs fine, but as the system had load on it,
Yeah,
when that compressor was running, it was pulling 30 amps.
yeah, she's toast inside.
Yeah.
She took a liquid bath a little early
Oh,
in her
I'm
career.
sure that's probably what happened. Is it probably munched a little bit, right? But we dug a little bit further, right? You put it in evacuation recovery mode. You hear that main EV going, and then you pull the head off, and right, it's rusted shut, right? Yeah.
Yeah,
So
yeah,
there's diagnostic steps to find the problem. Like I think we found the root cause is that EEV hasn't probably worked in years,
yeah, yeah, yeah.
and
Parallel
it's been
operation
right.
causes it to run into a vacuum, tripping low pressure. VRV3 built like a tank also has some weird workarounds that if you really watch it, she does everything she can to
It
keep
just
running.
worked, right? Like
It worked great. So like, I've seen a heat recovery REMQ system, two modules.
this was. Was.
Yeah, with a equalization line completely capped from the factory. Like someone didn't take the nipple off of the end; they just slapped a coupling on it,
Nice.
and they brazed it to the system. And so that system ran for 6.5 years before it continually tripped high pressure. And when it tripped the high pressure error, so essentially what it was doing this is it was the left side of the unit was trying to shift hot gas to the right side in parallel operation, and so it was running evaporator left, outdoor heat exchanger and cooling on the right. And when it did that, it tripped high pressure. And when it found that out, it would then shift the hot gas to the left side, and it would just do cooling on the right. And so it like almost self-corrected every single time. But it was assisted living. Nobody noticed it until it was trying to do a full load on the system where it was trying to use both outdoor heat exchangers at the same time, and it was hitting extremely high pressures at 98 degrees outside. It wasn't until then that I had to, what a creative diagnostic. It was running. I was like, there's no way between point A and point B, there's this much temperature difference on this line. Like it's hot gas on this side, it's hot gas on this side, but why is the equalization line cool in the middle?
Yeah.
And so I shut both valves on both sides. I let the pressure out, and I took a piece of silver solder and pulled the Schrader core out, and I dropped a piece of silver solder down, and it stopped. And I marked it with a Sharpie, and I pulled it back out, and I set it next to the line, and I was like, it's not going any further than 10 inches. The service cap is on there. So while I'm there, cut out the line, and sure enough, Bob's your uncle was there. And it turns out that they got the connection so hot that it melted the solder at the bottom of the nipple to where it had a little tiny pinhole where it's letting refrigerant through. Yeah, wild. Only time I've seen that. But again, basic science, going back to the root cause of stuff. Don't over assume. You kind of have to assume that everything is messed up all the time, which is the joy of VRF, right? We love working on this equipment because it's always so stressful. Everything is broken.
There's 900 potential causes, and you're there to find one.
It's so exciting. It's like spin the wheel and find out what the problem is this time, because it could be a number of things that you've never even seen before, like water dripping out of wires. That I found that video we posted on HVAC School where the water was getting into the conduit on the roof. It was pooling inside the conduit, and then there was a connection. Right, someone had wire nutted the L2 line, and so the wire nut was in the water. The splice was in the water, and so the pressure of the water up high on the roof was pushing the water into the wire down to the third floor panel. Nice. Where it was literally dripping in the circuit breaker, which then was causing the wire to the water itself was a path to ground.
Yeah.
But when it was a path to ground, it would cause the water to boil and dry because it was such a small amount.
Interesting.
And so you got voltage drips and drops and all over the place, and it was an awful smell, and it sounded like sizzling bacon, if you will. Good times.
It was a fun service call.
That is a fun one. Well, we changed all the boards. They changed all the boards because they blew from a surge. Then they changed the boards a second time because they couldn't get the fluctuations to stop. Then we disconnected everything except for the noise filters, and the voltage was still all over the place. When you remove the noise filters, no load at all, the voltage looked great. So it was only when there was a load on the wire back to the breaker, even just with compressors disconnected, motors disconnected, it was only with the noise filter. And the noise filter was, I guess, inducing a little bit of current through it in that straightening factor of it, that it was showing the imbalance. So
interesting.
Fun stuff.
Yeah. So I asked a coworker of mine, and they said that topic of annual testing for A2L sensors has not come up unless it's like a third party monitoring system, like you would have from like like a mechanical pen or something like that, where you would need
Sure.
a physical third party device. But according to some of the training literature, there's these sensors apparently are self testing. So they may have a procedure every once in a while that goes through and verifies that the signal is correct.
I'm thinking about the NO2 CO sensors that we are required to test for Honeywell for parking garages and stuff like that, where we have to go through and manually show with NO and CO tanks to show that they trip and test for life safety.
There's probably some UL standard that says it's okay for this sensor to be self testing, but I really kind of want to know what the self test is, how it works.
That's the thing. We're not here to get anybody tripped up on construction code or try to get to them enforce stuff, because we don't need more enforcement. Let's be honest. But we want to know how it works, right? And how do you ensure that it is working properly, and how do you test it? People are saying, "Oh, you just breathe on it. That'll fix it." It's like, it doesn't work like that.
Yeah, I don't think so.
It's not a thing. That's not how sensors have worked for a long time. I think they're getting it confused with the sensors in there are the same sensors that they use for heated diodes with their leak detector, which is not the same thing.
Mm-mm.
Optical sensors are different than heated diodes.
Well, there is talk that some of the sensors are based on sound. So this the science behind that, like, I get leak detection, audible leak detection, but like, does R32 have a different sound property when it leaks than something else? I get maybe.
So there's some really cool science here that I was looking into recently about leak detection, and the reason that we have ultrasonic, and it's because the way ultrasonic leak detectors work is the way that they move the air molecules around it. Essentially, it's a hyper frequency that you can't hear with your ears, but the leak detector picks it up because it's tuned for those frequencies to pick that up. But it's literally micro vibrations through air that is causing the sensor in that leak detector to trip because of the high frequency.
That makes sense. No, I get it. I mean, we've used ultrasonic sensors for refrigerant leak detection for a long time, right? Like, isn't that one kind of sitting right behind you there?
Yeah. No, this all UEI stuff and cool automation stuff.
What's that? What's the black box on the wall under your scope?
That's UEI's cable meter for determining length of cable.
Oh, that's cool.
I've been messing with it, and I'm trying to show that
resistance.
Well, that's what it's just a big predetermined resistance device. But I've been thinking about using it for determining length of wire to ITMs and ITCs that you don't know how long they are, to add to the length distance of communication issues.
I've been down that path.
Have you?
Yeah. Any board that it goes through is going to give you hell.
Sure, but I'm talking about like disconnecting from F1, F2 out.
Yeah. Yeah.
Because it's that spot where we've seen it before, where they hook everything up and it's an expansion to the system itself. And when they land two more outdoor units, it starts to bog down communication, where they're randomly getting U4s, taking forever. And it's like, well, I've got the 15.4 volts DC, and it's like, sure, but your data packets are getting lost. And, what's the distance of your wire? Well, it's like, it worked before until we added two more units on it and added the total wire length of how a D network system works. And it's like, well, that alone is probably enough to. So what's the solution? Adding another plus adapter is what resolved it, right?
DTA.
Yeah. Or so you could do DTA. But what about the service points past the DTA?
Oh, we're not worried about that.
I need to see my service checker points, Donald. Okay,
yeah, right.
DTA is a quick fix.
A cool difference with the D4 to D3. Let me see if I can find this picture real quick. The D4, at least from my understanding, is there's a little bit restriction on the not restriction, but difference on the length of wiring based on where the wire comes and goes. But now I think it's going to be more robust. Gosh, I can't find that picture. Anyway, so like this rule of like I think it was like 670 feet between an outdoor to the first branch selector, from branch selector to second branch selector. So there's now a rule that says that this is the max amount from point A to point B. But how I'm reading this slide is it says instead of like that total of 3,000 for all of the system, all 10 systems, right? Now you have the 3,000 for this com run, the 3,000 for this com run, the 3,000 for this com run, as long as the distance between A, B, and C is still that 676. I got to find the picture to make this make sense.
Gotcha.
So I think our D4 wiring is going to get better.
But I thought the wire length was less, in my opinion.
It looks to be about the same from what I remember.
Okay. Yeah, I know the communication protocol is different and you can't troubleshoot it with an oscilloscope. But it's never too late to learn.
Here we go.
Service Checker 5 is coming out.
Says who?
I don't know.
Nobody in America.
Nobody in America. That's right. If you know your sales representative complain about not getting Service Checker 5 because UK has it.
Trust me, I want one too. It's soon, apparently. It's soon.
If you're from the UK and you're watching this, please reach out. We would love to buy one from you.
All right, let's see. Share screen.
More service devices that we need, right?
Love it.
Let's just make sure that they don't require any training certificates for that one, though.
So the footage is slightly less, right? We lost about 1,000 foot.
See, I knew
furthest length. Well, the furthest length, right?
Okay.
But what we gained is the difference between the systems, right? So like total, we used to only be able to do, well, I guess not. That picture was really confusing. So I guess maybe it just got more complicated. Now we have to worry about between, centralized, between.
Before it was like, what is it? I don't care. Hook it up. Put it on that comm line, girl.
As long as you're less than
this.
Make it
happen.
Go.
Yeah.
Huh. I'll have to dig more into that because to me, when I read this the other day, it was like, hey, we're actually getting more out of this because now we can go per system. It looked like per system we could do this.
Well, so okay, but look at that. Different. But I mean, look at that there. Between DIV plus ADP unit and DIV plus ADP unit, it looks like between adapters you can do 328.
Yeah, yeah. It was 163 recently.
Yeah, 163. So you can put the adapters further apart, which is nice.
Yeah.
But I don't know. We'll see. We will see. 20 systems per line, 40 units. I mean, yeah.
That's a good thing, right? You can get a whole bunch of units on there. If they're all packed on the roof, then like your wiring is going to be shorter regardless.
Yeah. It's going to be more robust, but maybe just smaller. And this probably has to do with the data communication packets that are being sent at such a higher rate of speed.
Yeah.
We're going from dial up to, what is it? Fiber optic?
Yeah. We would.
That means we're getting sensor values every 1 second, right, Donald?
Do we need it every 1 second?
I mean, if we can do it, why not?
Seems kind of redundant, like pointless. It's a lot of extra data for no reason.
Maybe I like long CSV files.
I'm so worried about my room temperature changing by a 1,000th of a degree.
What if I need to?
Some people are.
What if I need to, figure out the molecular density and flow of refrigerant through the line by pooling my sensors every microsecond?
You're probably not using VRF.
I need to calculate the thermal conductance of the copper itself and the refrigerant flowing through it and create a measurement here. No?
I guess.
wrong technology.
Yeah. So this slide here, let me share this slide now. This is what I was looking at that made it seem like we get twice the amount of wiring. And maybe I'm just not reading it correctly, but like
reading is hard.
It is hard.
A to B.
A to B, that says we're getting whatever that is, and then B to F, so B to where's F? B to F, right?
There is
no F. B to C, okay. And then D to E, and then F to G, right? Now that's saying we give 6,500 feet.
Yeah.
Previously, that was that 3200, right? So it looks like
Uh,
it's doubled. But as long as we're not breaking this rule, right? This 656 feet between devices.
yeah.
So technically, it looks like we're getting double the amount of wiring.
Now I want to run it at 657 feet and see what happens.
Probably nothing.
Probably nothing.
There's got to be slot factor in there. It's probably like
Yeah,
750
10%.
feet. It's 900
Yeah,
feet, right? And
10 or
then they're just giving
20%.
us a happy number to make it easy.
Yeah.
But yeah, to me, it looks like 6,500 feet is double what we used to be able to do.
Well, notice how the 656 feet, they just took a
Times
zero
10.
away. Yeah.
Which is cool.
Yeah.
Whatever, that works, right? If you have 10
Yeah,
segments,
whatever.
then 656 feet times 10. Good.
The
But
cool
yeah,
thing is going to be learning how to troubleshoot the comms.
eventually, I guess. I mean, time will tell once we figure out
Oh,
that stuff.
I'm working on it. We're gonna crack the code. That's what it is. Because there's actually so many problems out there already. No, it's not any problems at all. I want to know. That's it. I just want to know. I don't need to use it right now. I don't have any problems with it right now, and I probably won't for a while. But new things come out. I need to know how they work.
Yeah, I mean, so far the only big issue that we've had is kind of when we do have a crosswire, reinitializing the branch selector just is kind of a pain in the butt because you got to let the capacitors bleed down and
And it's still mode or not hold return for
yeah, but
5 seconds
even
to.
and maybe we're just doing it wrong, but from what we've seen, just doing a regular reinitialization doesn't take because the branch selector never cycled power.
Mm. And it's not just turning it off and turning it on. It's turning it off and letting capacitors discharge.
And it took like a half hour to do that.
Ouch.
So
What about indoor units? Resetting indoor units or no?
it didn't like the indoor units have never mattered. You never had to cycle power to it, but you've always had to
Yeah.
cycle power to the box. And if
Yeah,
the boards aren't dying, then
everybody tells the story differently, right?
yeah,
You gotta do the first indoor unit, then you turn the box off, then you turn the second indoor unit off, and then you gotta turn the second indoor unit back on, and then turn the first unit on, and then turn the box back on, and then
get them hours.
yeah, hold your leg up in the air while you hold the return button for 15 seconds, and then spin around twice, continue holding the button.
That's something we're gonna have to play with and see if there's a faster way to drain these capacitors down. Because like we've tried to just unplug the capacitor and do the reinitialization, and then it gives you an error code saying, "Hey, this is not plugged in anymore."
UA 53.
Well, no, it was a different code. It was a UJ or something like that. A new code.
New codes. Love me some new codes.
Yeah.
More stuff to learn. Love it.
CH is the sensors. So CH11 through 14, I think,
Gotcha.
are the sensor trips. But
nice.
Tons of stuff on the horizon that we're itching to learn.
And we will, as we learn it, we'll unveil it here and share it, our real life experiences as we roll through the change from R410A to R32. This is a constantly evolving conversation. If you guys have any, and gals, we're not specific here, have any feedback about stuff that you're seeing in other markets and other things that we forgot to mention, questions that you might have, some customized solutions. This is about sharing knowledge and not about what Roman and Donald think should happen with the world. Nobody wants to hear that. We're here just connecting a voice for the community to talk about things that we're all dealing with on a daily basis, pain points as these things change, what they look like, how things are going to unfold, and how to make your life a little bit easier along the way. That's what we're here for. So feel free to reach out. I think we've covered, we beat this dead horse a lot, but life safety is pretty much the topic of the conversation today. It seems like.
I think so. We'll just things to look for. So
perfect. All right. Well, I appreciate the conversation, Donald. Until the next time.
Sounds good. See you, everyone.
See ya.
Bye.